Hello, my name is Mike Franklin, and I'm the course architect for Computer Science 6273 Parallel and Distributed Computing. In this course, we're going to be covering how we look at large tasks and decompose them into tasks that can either be done in a parallel fashion so that we can increase our throughput or decrease our runtime, or things that can be done in a distributed fashion so that we can get more horsepower behind the jobs that we're doing. While the ideas of parallel and distributed computing might seem to overlap quite a bit, well, of course, that's why we're teaching them in the same course together, they are distinct ideas. Parallel is about dividing tasks up into pieces that can be done at the same time so that we arrive at the same conclusion at the same moment, and we distribute and finish all of that work simultaneously. Distributed computing, although it's part of the parallel, is saying that we can take the same one task and decompose it into several different pieces and ask several different computer pieces to solve that example. As a means of illustrating the difference between parallel and distributed and why we like to study these topics, we look at this video. Here we see one child trying to pick up Legos from their giant mess, right? This mess of Legos that's out there, which seems to be their constant state, by the way. And as he's laboring to pick them up, we can see that his two hands are only able to pick up so many Legos per interval, per time period. And as he labors to work through this, he's going to eventually get frustrated and want to give up and just want to quit. I think we've all been there and we can understand this. As grandmother used to say, many hands make light work. So if we now revisit the same task, the mess of Legos out there, and we now examine it with many different kids, with 5 different kids with 10 different hands in there, all working at the same task. Because the task is easily distributed across the workload, we can see that we can work in parallel because there are 5 bins and 5 workers. And because of that, we can accomplish the same task, either complete it when we couldn't before, or we can accomplish it in much less time, and probably with quite a bit less frustration. In the idea of distributed computing, we also have to look at a couple of other ideas of how this workflow would work. If the job itself were able to be decomposed into individual tasks, then we can have people along these various stations. So we look at some standard dishwashing here, and we can see that in this routine, because the 5 laborers have distributed the workload, what they're doing is they're accomplishing one task, but they're doing it with 5 different workstations. So you see that one person is bringing over the dishes, another person is rinsing them, another person is drying them, another person is putting them in the dishwasher. We see that they've distributed their workload. They're still only accomplishing the same single task, but they're doing so in a much more powerful or a much quicker fashion. It also helps us so that each one of those machines, each one of these folks, is doing a little bit less labor than they would have to on their own. We also have to understand that when we look at these parallel and distributed algorithms, we're going to find out that there are tasks that do not decompose very well into distributable or parallelized tasks. As an example, revisiting this, the dishwasher scenario, we can see that if all 5 people were tasked in parallel to wash the dishes, well, not only would some hilarity ensue, we would also recognize that this is not going to be very efficient. All 5 people simply can't put their 10 hands inside the sink to wash those dishes at the same time. Now, I hope that these little illustrations have shown you what we're going to study this semester, and that's this idea that we can take large jobs, large tasks, large goals, and we can either decompose them and distribute that workload, or we can find ways to do parallelization where we can take this task and get it done in much more efficiently or much less time. Now, there are often jobs that we can do both in parallel and distributed, and so that's why we study these tasks together. They are closely related, but they are distinct in their own right. I hope that you're going to enjoy this semester as we cover these topics, and I hope that you'll enjoy how we spend time getting into the code and getting into the algorithms that make all of this work. Thanks so much for joining me.